Hello everyone, welcome back to Algebra 1 with Miss Betsy. I'm glad you're here to take this journey through the study of Algebra 1 with me. If you're tracking along using the same text that I'm using, I am using Algebra 1 for Christian Schools. It's published by Bob Jones University Press. It's the second edition. Now if you're not using the same text that I am, it's no big deal, because we're going to be studying the same information that you would be studying with any standard general Algebra 1 book. What we're doing in this lecture is we're continuing our discussion about how to come up with the graph of the equation of a straight line if you're given certain pieces of information. So we are going to be going over a brief little review, but you know what I almost forgot? Almost forgot my lame joke. And even before I do the lame joke, I need to tell you that if you are tracking with me, I am on page 255 of my text. I'm in section 6.8, and the title of our section is Finding the Equation of a Line Given 2 Points. And I know exactly what joke I am looking for. However, I can't seem to find it. Okay, here we are. What do piggies practice in karate class? They practice pork chops. Hi-ya! And no, I was not doing karate with my wrist. Anyway, continuing right on with our lesson, we saw that we have learned so far that if you're given the slope of a line, which is a measure of how rapidly or how steeply a line increases, how rapidly that line decreases. If you have the slope and the y-intercept of a line, which is the point where the graph of the line crosses the y-axis. So if we had those two pieces of information, it was very, very easy to make a graph of that straight line. We learned that there is a particular form of the graph of the equation of the line. It was called the slope-intercept form of the line. And that formula says that y is equal to mx plus b, and that m is the slope of the line, and b is the y-intercept. We had also learned earlier that they have something that's called the general form of the equation of a line, or the standard form of the equation of a line. And let me go ahead and write that in here as well for us, just as a part of this brief review. And that says that ax plus by is equal to c, and this is standard form or general form. Of the equation of a line. And right here, a, b, and c can represent any real number. They can be integers, which are positive or negative numbers. It could even be 0. We could have 2y is equal to 3, because we would have 0x. We can include 0, we can have fractions, we can have decimals, we can have radicals. The only limitations we have on this is that a, b, and c have to be real numbers. This is what we call the standard or the general form of a straight line. It's also called a linear equation, because when you have an equation that looks like this, it's first degree, the exponents of x and y are only 1. First degree equation is always going to graph out so that the ordered pairs, we know that the solution to this equation is an ordered pair because we have an x value and a y value. Those ordered pairs are always going to lie on a straight line if they are a solution to this particular equation. And as we continued to study about linear equations, we learned that ax plus by is equal to c form of a line wasn't particularly valuable because there's not a whole lot we can do with it. But we did learn right off the bat that our slope-intercept form of a line is extremely valuable. This is the slope-intercept form of a line, and you need to have this automatically come out of your mouth Anytime I say, how do you find these, what is the slope-intercept form of a line? You need to be able to say in your sleep, y is equal to mx plus b, m is the slope, b is the y-intercept. Because you're going to have lots of problems that say, graph a line that has a slope of 5 and a y-intercept of 0, -2. For example, now of course they're not going to give you where that's the only problem. There's going to have problem after problem after problem where they give you the slope, they give you the y-intercept. They want you to graph it, but before you can graph it, you have to give the equation of that line. So they might say give the equation first and then graph it. How do you find the equation? Given the slope and the y-intercept, you just substitute things in. What does this tell us that the slope of the line is equal to? The slope is 5. 5 times x plus what? What's the y-intercept? The y-intercept is the y-coordinate of the point at the place where the graph of that line crosses the y-axis. The x-coordinate's always going to be 0, so the y-intercept is a -2. Y is equal to 5x minus 2 is the equation of a line that has a slope of 5, it's a very steep line, and a y-intercept of -2. So you see how very easy it was to give us the equation of a line if we have the slope and the y-intercept, because we use the slope-intercept form of a line. And then we went on into our next section, and we said, okay, easy enough to give the equation of a line if we have the slope and y-intercept. But what if we have the slope and any point? You know, not where it's crossing the y-axis, but just some random point. So, for example, let's say that we have a slope of 2, m is equal to 2, and the point 1, 4 is on the line. What are we going to do here? Well, can we use our slope-intercept form of the line? We think, well, that would be really good. Y is equal to mx plus b. Y is equal to 2x plus, and Miss Betsy, you just said it's the y coordinate, 2x plus 4. Is this correct? No, you can't use the slope-intercept form of a line because the point 1, 4 is not the y-axis, is not the y-intercept. For the point to be the y-intercept, the x value has to be 0. So no, that doesn't work. So what in the world are we going to do? Well, we have another form of the equation of a line, and it is called the point-slope form of the line. And I told you that any time that you used this formula, just go ahead and write it down. Point-slope form of a line. So that you would be able to memorize it. And the point-slope of the form of the line said y minus y sub 1 is equal to m times x minus x sub 1. What we have here is m is always the slope, and the x sub 1, y sub 1 are the coordinates of the point that you're told is on the line. So this formula is a little bit more involved, but you still just have to substitute in values. So we have y minus the y coordinate, which is 4, is equal to m, which is our slope, 2 times x minus the x coordinate, which is 1. Now, before I finally ended up with a successful lecture on video for y'all to do this, I had messed with confusing the coordinates of my point. Actually, I think I had one that was 1, 3, and I ended up using a 3 for both the x and both the y. So take the time, always, you've heard me say this over and over, when you're substituting in values for your variables, take a second and go back and make sure you've substituted correctly. So what's the y coordinate? It's 4. What's the slope? It's a positive 2. What's the x-coordinate of the point? It's a 1, and I'm subtracting it. So I'm good to go now, and I can keep on continuing with this lecture. I have y minus 4 is equal to 2x minus 2. And you would think, can I just leave it at this point? I've substituted everything in. Well, no, you really can't. You need to either have your equation of the line be in slope-intercept form or in standard form of the equation, in standard form for the equation of the line. Typically, people are going to have you just put this into slope-intercept form, because usually when they ask you to find the graph of a line, find the equation of the graph of a line, they're going to ask you to go ahead and graph it. And it's easier to graph if you have used the slope-intercept form of the line. So what do we need to do? To put this in slope-intercept form, we just solve for y by adding a 4 to both sides of the equation. And we have y is equal to 2x plus 2. This right here is the equation of a straight line that has a slope of 2 and it passes through the point 1, 4. And if we now went ahead and graphed this equation, we would put a point on the 2 on the y-axis. Our slope is 2, so we go up 2 units over 1 to get our second point, connect this with a straight line, and you'd be finished. So those were 2 ways that you could come up with the equation of a line given certain pieces of information. Both of them required that you already know what the slope of the line is. We're finally today getting to the third pair of pieces of information that you can have and still be able to come up with the equation of a straight line. And now here they're not even giving us slope. No slope, and all they have is any 2 random points on that line. So how can we possibly come up with the equation of a line? We have the slope-intercept form of a line, which is y is equal to mx plus b. We have the point-slope form of a line, which is y minus y sub 1 is equal to m times quantity x minus x sub 1. Sounds like gobbledygook gibberish that I'm speaking, but it really isn't. But both of those equations had an m in them, didn't they, where they contained the slope. Am I going to come up with another equation for you? Nope. I'm going to ask you to use the pieces of information that you have. Let's say that we have 1, 3, and 4, negative 2. 1, 3, and 4, negative 2. And this is example 1 from our text that's on page 255. And it says, write the equation of the line that passes through these points. You have to have slope. How are we going to get slope? Well, flip back in your book a few sections, go back through your homework a few sections, go back a few days in your brain, and you think, oh, slope is the relationship between 2 points on a line. And look at that, I have 2 points on a line. We said that slope was m, and the slope was the vertical change divided by the horizontal change. So in words, slope is the change up and down divided by the change left and right. That can also be used as delta y over delta x. Now this is not red triangle y, but this is delta y, delta x, because this triangle shape is delta in the Greek alphabet. Now, maybe up until now you've thought about a delta like the Mississippi Delta or the Nile Delta, and it's where there's an area at the mouth of a river where there's silt that's discovered. It does have somewhat of a triangular shape, but it's mostly some land, an islandish type thing. How's that for a word? Islandish. Where the silt from the river has been deposited at the mouth of that river. That's not what this delta is. It's just referring to the Greek letter delta, and it simply means change. The change in y, the change in the y values, vertical change up and down, divided by the horizontal change. Another way that we had of describing this was to say that it was the rise over the run. And this terminology is used a lot in carpentry when you're laying out stairs or when you're doing the slope of a roof, the pitch of a roof. The rise is your vertical change. The run is how far you're walking in one direction. Another way that we saw that we could determine what slope is that it was the difference of the y values divided by the difference of the x values of two separate and distinct points. And this is what we're going to use in order to take any 2 points of a line and come up with the equation for it. We're going to use those 2 points to calculate our slope. And this is how we're going to do it. We're going to remember that slope is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. It's simply the difference of the y coordinates divided by the difference of the x coordinates. And when we're doing our red solution here, we're going to say that we have point 1 is first and point 2 is second. So our second y coordinate is a negative 2 minus our first y coordinate is a 3. The difference of our y coordinates, the difference of our x coordinates. Our second x coordinate is a 4. Our first x coordinate is a 1. Negative 2 minus 3, negative 5, 4 minus 1 is 3. So our slope of this line, we've calculated it. We now know that our slope is a negative 5/3. Now, you might be still confused or still be scratching your head a bit and thinking, yeah, but you're going to get a different value if you label your points differently. Well, let's see what happens. For our blue calculations, we're going to use different points as point 1 and point 2. And I'm going to remember that slope is the difference of the y values divided by the difference of the x values. And I'm going to go ahead and substitute this in and see what we end up with. Our second y value is 3. Our first y value is a negative 2. And you think, uh-oh, Miss Betsy, we've already got a problem. Because we had a negative 5 here, this is going to be a positive 5. You're right, 2 different values, but hang with me and let's see what happens. Our second point, our x value is 1. And our first point, what we're calling point 1, the x value is 4. So I have 5 divided by a negative 3. Exactly the same thing. Remember, when you have a rational number, something that looks like a fraction, it doesn't matter if you have negative 5 divided by 3 5 divided by a negative 3, or the opposite of 5/3. These are all three different ways of naming the same rational expression. So what we've illustrated again here is it doesn't matter what point you name point 1, what point you name point 2 when you're finding the slope. Okay? So now what are we going to do? We've used the pieces of information that we have, the 2 points that we have, and we've calculated what our slope is. Our slope is a negative 5/3. Now what are we going to do? Think hard. Negative 5/3 is equal to m. Exactly. We're going to use the point slope form of a line. Y minus y sub 1 is equal to m times x minus x sub 1. We have to use the point slope form of the line because we're given 2 points here, but neither one of them is the y-intercept. How do we know if it's the y-intercept? Remember that x value has to be 0. Okay? Just going to substitute in here. Now which one of these points do I want to use? Doesn't matter, you can use either of them. I'm going to do as the least amount of work I can, so I'm going to pick the 1 and the 3. So I have y minus the y value is equal to the slope, negative 5/3 times x minus the x value. Y minus 3 is equal to negative 5/3 x plus 5/3. Negative times a negative is a positive, isn't it? Plus 5/3. Now, I'm going to go ahead and put this in the slope-intercept form of the line. I'm going to do this by isolate my y by adding a 3 to both sides of the equation. 5/3 x plus 5/3 plus 9/3. Now see how I sort of snuck that in there? What did I do? Is that legitimate? Yes. We're keeping our equation in balance by adding the same quantity to both sides of the equation. 3 has the same value as 9/3. You could have taken an extra step in here and said negative 5/3 x plus 5/3 plus 3, and then written this step here where you renamed 3 as a fraction over 3 so that you could add those two together. But I chose not to do that. And I come up with the equation y is equal to negative 5/3 x plus 14/3. And this, my friends, is the equation of a line that passes through the points 1, 3, 4, negative 2. And what can you tell from this? You can tell that it has a slope of negative 5/3. And where is the y-intercept? You now know that the y-intercept is indicated by the coordinates of the point 0, 14/3. So the graph of this line goes downhill because it has a negative slope, and it crosses the y-axis, or it intersects the y-axis at the point where y is equal to 14/3. That's all that's really involved in these. Let me go ahead and take another example for you. This says, write the equation of the line passing through negative 5, 2 and 3, negative 4. What is the y-intercept? So let's go ahead and clean this board. And see, this time they asked for the y-intercept. They didn't ask it last time, but I showed you how to do it, didn't I? All you have to do is put that equation into the slope-intercept form of the line and read off what the y-intercept is. So the 2 points that we're given are negative 5, 2 and 3, negative 4. What do we have to do? We have to calculate the slope first. Doesn't matter which one of our points we call point 1. No, it doesn't matter at all. 0.2, 0.1, so I'm just going to say this is 0.2 and this is 0.1. And I'm going to remember that slope is the difference of the y values divided by the difference of the x values. 2 minus a negative 4. Slope is 2 minus a negative 4 divided by 2 minus a negative 4, negative 5 minus 3. Negative 5 minus 3. And let me verify. Okay. Remember what I said just a moment ago. Take the time to make sure that you've substituted correctly, because you don't want to redo your homework. I don't want to redo my videos. My second y coordinate is 2 minus a negative 4. My second x coordinate is negative 5 minus 3. So I now have 6 divided by a negative 8, so my slope is a negative 3/4. Make sure that you reduce your fraction to lowest terms. Now that I have a slope, I can use my point slope form. What is my point slope form of a line? Well, that's the one that says, we use that silly language that says y minus y sub 1 is equal to m times x minus x sub 1. Every time you're using your point slope form of a line, write that equation out. You won't have to spend any time memorizing it at all, because you'll just automatically learn it. Now I'm going to substitute. But what point am I going to use? I'm going to pick the easiest point. What's my easiest point going to be? It doesn't really make a whole lot of difference here. So I'm just going to pick this first point. What's the y value? Y minus 2 is equal to m, which is negative 3/4 times x minus a negative 5. Do something that makes it jump out to you that you're subtracting a negative, so that you don't mess up your problem because you've dropped the negative sign. So I have y minus 2 is equal to negative 3/4 times x plus 5. Okay? Still have to do my algebra. What I was doing just now was looking at the book. They chose to use a different point. Y minus 2 is equal to negative 3/4 x, negative 3 times 5, minus 15/4. Remember I said you have to be comfortable working with fractions? We're going to add 2 to both sides of the equation, but I'm going to rename it as a fraction over 4. Y minus 2 plus 8/4 is equal to negative 3/4 x minus 15/4 plus 8/4. Subtracted a 2 here. In order to isolate the y, I have to add a 2 to both sides of the equation. But I'm going to have to be able to add fractions over here, so I just went ahead and renamed it. Now I have y is equal to negative 3/4 x minus 7/4. And this, my friends, is the equation of the line. So let's go check and see. Y is equal to minus 3/4 x minus 7/4. What's the y-intercept? The y-intercept is indicated by an ordered pair. So your y-intercept always has an x-coordinate of 0. Y-intercept is the point 0, negative 7/4. It's not a hard formula, but if you're not careful and not comfortable with fractions, you've got a problem. So at this point, if you're still struggling with fractions, get some supplemental help somewhere, make sure you can do fractions. Okay? And our problem goes ahead and brings out the point that if we wanted to check this equation, can take this equation, substitute in the point that we did not use, the 3, negative 4, and you would find out that you ended up with a true statement. If you did not end up with a true statement, you've got a bit of a problem. You've got to go back and see what you've done wrong. Go ahead and take the time to look at your text on page 256, and they'll illustrate for you how they actually went through and checked their problem. I'm not going to take the time to do that. Let me do one more quick illustration for you with 2 more points. And see what we have. This says write the equation of the line passing through 7,4 and 7,2. 7,4 and 7,2. How do you find the slope of a line? You subtract the y values and you divide that difference by the difference of the x values. And I just wrote down what the answer was. I have 7 minus 7. I have a slope 2 divided by 0. Is it possible to divide by 0? No. Division by 0 is undefined. So we would say the slope is undefined, or there is no slope. And we learned, what did we learn about the fact that there's no slope? We learned that horizontal lines have no, I'm sorry, I said horizontal lines. We learned that vertical lines have no slope. What did we learn about horizontal lines and their slope? Okay. Did you notice that when I put this S here, I said horizontal lines, so I put an S on slopes? Let's take a second here to think about what we know about horizontal lines. Horizontal lines have a slope of 0. If you're walking along straight, there's no change in elevation, you're not going up or you're not going down, that's a horizontal line and it has a slope of 0. Having a slope of 0 is not the same as having no slope. No slope is when you're trying to divide by 0, which you can't do, it's undefined. So a vertical line has no slope, a horizontal line has a slope of 0. I just wanted to take a second to remind you of that. The slope's undefined, so you've got a vertical slope. You have a vertical line. If we have our Cartesian coordinate system here, what are you noticing about the x's? Yeah, the x's are the same coordinate. Same coordinate for both points because 1, 2, 3, 4, 5, 6, 7. You have a vertical line, don't you? So your x values are going to be the same. And there is no y-intercept because it's a vertical line passing through the point where x is always going to be equal to 7. And in order to have a y-intercept, the x has to be 0, doesn't it? So this would be the graph of this line. And the way that you write the equation is simply x is equal to 7 because what you have is a vertical line that every point on that line, like I just sketched for you, has an x-coordinate of 0, of 7. On and on forever. It's just a straight line that passes through the point where x is equal to 7. That's the end of section 6.8. I'll see you next time.